Hello, welcome to 3.3 Rules for Differentiation. And I want to go over two of these with you right now. Let's do this. Rule 1 is the derivative of a constant function. And it says if function f is if f is a function with a constant value c, then the derivative of that constant value equals 0. In other words, if you had, say, f of x equals 3, then f prime of x would equal 0. So let me explain why real fast before we just dismiss this as, oh, okay. If you graph f of x equals 3, of course that's a flat line that goes through here, something like that. And remember what the derivative is. It's the derivative of a point on, the slope of a point on this line, and it's all the same, and it's all equal to 0. So the slope equals 0. Therefore, the derivative of any constant function, any number, is going to have a slope equal to 0 because all of the graphs are going to be flat lines with slope equal to 0. I think that one's pretty simple, but it's important too because anytime you have a number and you have to take the derivative of it, it becomes 0. Now, let's look at the next one. The next one says, Rule 2, and this is now letting the cat officially out of the bag, the power rule for positive integers, powers of x. So if n is a positive integer, then this is true. All right, this rule right there is now true. Now, I'm going to pause this and let you guys write this down. So what this means is this alleviates so much problems that you've had in the past. So, for example, instead of using the rule of a derivative, you can just do this now. So if you have something like x to the 5th power, and I ask you to find the derivative, well, instead of going, f of x plus h and using the derivative of it, you can just apply this now where n is 5, so that's the n right there. This is called the power rule. And according to this, we would have, if we substituted the 5 in for the n's, it would look like this. And believe it or not, that turns into 5x to the 4th. And if you do use, and I invite you to try it, use the definition of a derivative, like we have in the past many times, and do this, you will get 5x to the 4th when you're done. And it takes that 5-minute problem and turns it into a 5-second problem. So I have some you try these now types of problems here. I want to show you these. So let's say we had to do these 4 or 3 problems right here. The first one being f of x equals negative x squared. Well, if you had to do that, this 2 would be represented by the n. So this is basically a negative 1 right here. All right, that's negative x is negative 1x. And this is touching on another rule we'll do tomorrow officially, but it basically turns into negative 1 times, and then it would be 2x to the 1st, because that would be 2 minus 1 right there. You subtract 1 off the exponent and bring this value down in front, okay, based off the power rule. So this would turn into negative 2x. Final answer. No need to say 2x to the, or negative 2x to the 1st. This one here, so this would be f prime of x, by the way. So on this one, f prime of x, or the derivative of f of x, would be resolved on the top first. So this on the top, you would basically cover up the bottom and look just at x cubed. And of course, x cubed becomes 3x to the 3 minus 1 power, which is 3x squared. And then, of course, you would reduce this right here. So this would cancel, and you would get x squared. X squared, final answer. And if you had something silly, like x to the 3.57 power, and I'll just try to do that definition on that, this would simply be 3.57x to the 3.57 minus 1 power. So this would become 3.57 x to the 2.57 power. And these two rules, the constant rule and the power rule, makes your life so much easier. You guys have a fantastic day.